Our group decided to create a project using thermoforming. Before we can get to the project itself, a more thorough understanding of thermoforming would be helpful. Thermoforming involves heating a plastic sheet and using a difference in pressure to shape it around a mold. Thermoforming can get tricky when you're dealing with thinner products because if the pressure difference is too high, the plastic will yield and ruin the shape of the product. Once the desired shape is obtained and the plastic has sufficiently cooled, the product can be removed from the mold. Any additional plastic is trimmed from the edges. The process seemed appealing for a project because of its relatively low product-specific investments. As such, our group was able to obtain the necessary materials cheaply. Hopefully by the end of the video, anyone that is new to thermoforming will have a greater understanding of how this process works. To start out, we first had to decide what object we wanted to use. In order to create the mold, we decided to use a familiar shape, the Georgia G. We started out by posting a picture of the G into AutoCAD for tracing it out, using simple arcs and lines. Here, we created a plane and extruded the G in order to get the desired shape. Once this was completed, we saved it as an STL file, then placed it into the 3D printer to begin printing. Here you can see the print going, which took approximately 8 hours to complete. We chose medium amount of fill because the part wasn't going to be under much pressure during thermoforming. This was because we designed it for a simple vacuum cleaner to be used for suction. Here, the final product measures 7 inches long, 4 inches wide, and 3/4 inches thick. The first thing we needed to do to construct our thermoforming box was cut the wood. We had some scrap plywood that we were able to use for the base and sides of the box. On one side piece of the box, we drilled a 1 7/8 inch hole to attach our shop vac. We bought a piece of pegboard and cut it to size for the top of the box to allow suction to reach the plastic around the part. We used liquid nails to glue the sides of the box to the base and to each other. We then drilled pilot holes and used screws to fasten those pieces, as well as adding more liquid nail to the edges to ensure a tight seal was created at the joints. Lastly, we used liquid nails and more screws to fasten the pegboard to the top of the box tightly. The final dimensions of the box were 9 inches long, 9 inches wide, and 4 inches tall. Our intended product, the G, didn't quite hold up the way we intended. This was due to the fact that the mold and plastic plates used as a material were obtained independently, and therefore the dimensions didn't work between the two. For future considerations, we would most likely design the mold to be slightly smaller or order plastic sheets of adequate size. In addition, drilling holes in our mold would have helped vent the air beneath the product. As a proof of concept, we attempted to form a few different shapes with household items. Some turned out to be of pretty good quality, such as the car and the number 4. However, certain molds didn't quite have the best geometry for standard thermoforming in the way that we approached it. For example, the glass cup didn't work well as a mold due to its depth and the thickness of the plastic as it was being heated. This resulted in the plastic pulling apart as it was being stretched too far. Overall, this project encompasses a lot of the good with thermoforming and demonstrates the limitations that have to be navigated with better design considerations.